Thank you for the introduction, Annalena. And thank you, ORKG, for letting me participate in this initiative. It was a very informative and well-structured project. So let me share my screen really quick. Okay. So, hello everyone. My name is Savvas Kastanakis and I'm a PhD student in the School of Computing and Communications in Lancaster University. And today I'm going to present a comparison of the state-of-the-art works that take place on privacy-preserving deep learning, on machine learning as a service. So these probably are unknown words to some of you. To be honest, they were unknown words to me also before I do this comparison, but that's the good part of ORKG that helped me learn so many subjects. So let's take things one by one. First of all, in a business environment, we can use artificial intelligence tools. We can use the wider umbrella that is called machine learning and the more specific umbrella of machine learning, which is called deep learning. And we can use these tools to do prediction tasks and decision-making tasks. So usually, either in a machine learning or deep learning model, we take an input, which is a data set that someone owns. We pass that input into a mathematical model, and the mathematical model tries to draw some lines between our data points. Or in other words, it tries to fit a mathematical function onto this data. Then that mathematical function can be later used so that we can make predictions about new data points. And that's more or less how machine learning works. Now, not everyone is a machine learning engineer, but machine learning has lots of applications in today's life. So someone thought, why not we provide machine learning models or deep learning models through a platform to those who don't know how to make their own models. And that is called machine learning as a service. So imagine all these predictive tasks to exist somewhere in the world in a set of servers. And this set of servers or computers is what we consider the cloud. So we can say that this is a cloud platform. So these machine learning models exist in this cluster of servers. So someone does not need to build their own model. They just need to access this cloud platform, probably pay them, and then get back the results they need. The bad thing is that these clients need to send the data they own to these platforms so that they can do the training and inference tasks, and that poses some privacy concerns. Now, let's first describe the pipeline of machine learning as a service. So imagine that we are the orange person that sits in the bottom of the monitor, and we have some data in our hands that we want to utilize so that we can make predictions about our company. Probably these are financial data. So we send through the blue line our data to the cloud platform. In that cloud platform, there are these models that actually train on our data, and they try to create these lines that actually fit our data so that later we can make classifications. As soon as we have a stable model on the cloud and we have it trained, then we can send some other new data, which is this black envelope here, and we can ask from the trained model to make a prediction. Then the trained model receives this data, makes a prediction, and sends back through the green line the inference results to the clients or to us. Now, in this pipeline, there are some concerns, some privacy and some security concerns. Even though machine learning as a service seems a very important and promising tool, it introduces some data privacy challenges for those who hold the data and some security challenges for those who hold the models. Those who hold the data are concerned about the safety and privacy of the data on the MLAS platforms, and those who hold the models worry that some clients could pose some adversaries could pose as clients, and then sending fake data, they can try to reverse engineer the production models. So we can see that in the pipeline that someone could actually interfere when you send training data to the server. Someone could interfere the traffic when you send data for inference, or someone could send data and then try to interfere the results from the model so that they can try and understand what parameters are used in the model and actually steal the model of the platform rather than the data of the clients. So to address with this problem, usually when you have privacy concerns, you address the problems with encryption. So someone said, why not encrypt the data before we send them to the client, and why not encrypt the results of the models before we send them back to the customers? So that's actually what happened. Before you send the data, as we saw earlier, you send your training data set through an encryption module that encrypts your data in some gibberish that no one can understand. So now you have an encrypted data set. That encrypted data set is sent into the cloud server, and now the cloud does something quite difficult here, but at least we are in the state of the art when it comes to that. It trains a model on encrypted data. So it doesn't care about the actual content. It doesn't have to decrypt what you've sent it. It just trains a model on the encrypted data. So as soon as you finish training, you have a trained model that now can be used for the actual tasks, for the inference and the prediction and the decision-making tasks. So to that end, the client will send a new dataset, a testing dataset. Probably that would be encrypted as well. The cloud server is going to receive it, and then it's going to pass it through the inference module of the trained model. Then, since we want to save somehow the model as well, the result of the trained model is going to get encrypted, and then it's going to be sent back through the cloud server to the client, who now decrypts it and receives the actual results in his hands. So more or less, I try to simplify it as much as possible, but this is the actual pipeline that takes place in privacy preserving deep learning on cloud platforms. It may sound simple, but these boxes here that say encryption are the nasty stuff, and that's where the whole research community focused into. Now, imagine that you're a researcher in privacy preserving deep learning. So if I was a researcher and I was using ORKG in, let's say, 5 or 10 years time, I would like to have the state of the art in front of me. What that means that I would like to know which machine learning or deep learning model is the one that has the best accuracy when it comes to predictions, but also, since we impose that um, um, encryption and decryption tasks, we impose some computational overhead. So I would like to know which model is fast enough so that I can use it for my research. So that's more or less what this comparison answers. And you can see here that we have plotted the accuracy of all of the state-of-the-art models, and we can see that CryptoDL and secure neural network achieve the highest accuracy among all PPDL schemes. And also we plotted the inference time that these models need to take the input, encrypt it, create the inference, and then send it back to the customer. And you can see that there are some models that achieve near zero inference time, and one of them, for example, is SecureNN. So we know that SecureNN is also both a very accurate model, but also a very fast one. So we have the top model that we can use for our research, for example, if we were PPDL researchers. Now, the whole idea of this presentation is to explain that there is a subject which is called machine learning as a service, and that technology actually leverages AI to enhance decision making. The adoption of MLAS introduces some privacy and security concerns, but privacy preserving deep learning techniques arise as a possible solution to the problem. And this presentation was a comparison of the state of the art PPDL schemes for researchers that are willing to understand what goes on in that field. Thank you very much for your time, and I would be happy to answer any questions.